All right, so there's a initial slide on Desmos just to kind of check with yourself. How are you doing with memorizing the unit circle? How comfortable do you feel with identifying all 16 angles and degrees, all 16 angles and radians, all of those coordinate points? Notice you can select all, most, a few. Hopefully no one is selecting this. So just want to make sure that it's on the forefront of our mind, that this is an important concept that we need to be really comfortable with. So a reminder too then on the next slide, just of what we can do, some resources for us to help memorize / practice the unit circle, some really good videos that will help you kind of remember it, a nice interactive website that will help you practice identifying all the components. So I encourage you to visit those if you were kind of marking down around here in this list from the previous slide. Okay, so today we are going to investigate two transformations of the graphs of y equals sine of x and y equals cosine of x. So to get started, I ask you to view the graph of f of x, or we could think about as y equals sine of x and of cosine of x, okay? So you'll see the red section shows one period. Remember, that's one cycle. As soon as I go through this red section, I start repeating that same behavior to the right and also to the left. Okay? Within that one period, we're seeing what are known as the 5 key points. Those were the points that came directly off of the unit circles. Okay? These points are those of the max, the min, and the intercepts. Okay? We see in blue over here to the right a section of the graph of y equals cosine of x. That blue section is one period of the cosine function. Again, showing those 5 key points, those 5 points that we picked off the unit circle the other day. So we're seeing that we have the max, intercept, min, intercept, max. Okay, so I ask you to identify how are they similar, how are they different. So go ahead and pause this video and take a moment to think through that. Similarities that hopefully we're seeing, amplitude of 1, we have domain of negative infinity to positive infinity, we have a range of -1 to +1, we have that period of 2 pi, maybe some others that you're noticing, some similarities that you see between those two curves. Definitely feel free to write those down, but those are kind of the key ones that I'm looking at. The difference that I notice and that I want us to focus on is that our sine curve starts at the midline and our cosine curve starts at the max. Okay? So when I'm thinking about starting, I'm thinking about when our angle is 0. So here we're at the midline on our sine graph. Here we're at our max on our cosine graph. We will repeat, right? We'll go through one cycle and end at the max after one cycle. And cosine on sine will go through one cycle and end at the midline at the end of one cycle. Okay? So you might have found other differences. Totally awesome, totally great. But these are going to be the ones that I focus on. On the next slide, in Desmos, so Desmos slide 6, you're asked to specifically play with the value of A and the value of K for your sine graph. Notice the hint is kind of suggestion, I guess, is to change one value at a time. And then on slide 7 in Desmos, you're asked to do the same for cosine. Okay, again, changing one thing at a time. So go ahead and pause this video, spend some time playing with 6 and 7, making observations on how changing A and changing K affects your curve. And I noticed there should actually be parentheses around that quantity x minus h. I apologize. That is shown in Desmos, but not on this screenshot. So pause the video, play on Desmos slide 6 and 7, and then once you're done there, you can start the video to hear the conversation about slide 8. So in both the sine curve and the cosine curve, A is changing the amplitude. It's changing the height of the function from its midline, right? It's changing the distance between the min and the max, right? It's kind of stretching our function vertically. I want us to look at specific ways that this happens, okay? So when our absolute value of A is greater than 1, this stretch is away from the midline. When the amplitude, the absolute value of A is between 0 and 1, so some fractional value smaller than 0, the stretch is towards the midline. And perhaps a better word to use there would be compress. And I would encourage you to go back to that slide. Let's see, it was slide 6 that kind of dives into where you can change these. Well, slide 6 or 7, you can actually play with the A values and look for, confirm with yourself that these are actually happening. Now, when A is less than 0, so when A is negative, the same kind of things are happening as far as the magnitude of these numbers, right? If it's a negative number greater than 1, we're stretching away from the midline. If it's a negative number between 0 and -1, we're compressing towards the midline. But if A as a whole is less than 0, so aka negative, we have a vertical reflection. So that's kind of changing direction. If we were thinking back to the unit circle to pick off our points, the changing the direction around the unit circle that we would traverse. All right, excuse the bell there. K is changing the the midline. So this is the number of units that the graph has been shifted in the vertical direction from its usual position. As a reminder, y equals k is going to be the equation of our midline. All right, on our next, and this is happening, both of those were happening for either sine or cosine. Hopefully you notice that difference, right, that we mentioned previously, where cosine is starting at a max and sine is starting at the midline. But other than that difference, the change of A and K are staying the same between sine and cosine. So we're going to talk about how to sketch these graphs by hand. So the first thing that will be important for us to do is identify the midline, okay? The midline is where we base kind of everything off of. So our midline is -1, so it's y equals -1, that's our k value. We are then told to determine if the curve starts at the midline, meaning it's sine, or a max or min. We'll talk about the differentiating that here in a little bit. So max or min being cosine. So I see that it is sine. All right, so a sine function we know is going to start midline. If it's a positive A value, we'll go up to the max, come back down to midline, then to a minimum, and then back to our midline, and that is one cycle. So again, sine is starting at the midline, so I'm just going to kind of make note of that here. 3 says mark off the period. When our b value is 1, which is what we're going to see today, the period is 2 pi, right? When we don't have any effect to the argument, the input of our sine or cosine function, our period is 2 pi. That means it takes 2 pi units to complete this behavior, okay? There's symmetry in this behavior. So if I were to think about dividing that length, 2 pi, into 4 pieces, right? So 1, 2, 3, 4 pieces, that's gonna help me decide where I put the max, the midline, and the minimum. So part 3 says mark off the period. Oh, we already did that, sorry. Part 4 says divide the period into fourths. Okay, so dividing 2 pi up into fourths, I'm gonna have to go in half to give myself pi. I'm gonna have to go half again to give us pi over 2, half again to give 3 pi over 2. I'm gonna erase those just so that when, the numbers at least, just so that when I go to plot the points, it's not too crowded. But pi over 2, pi, 3 pi over 2, 2 pi, all the angles we're going to have to hit to cycle from our midline, max, midline, min, midline. Okay? So 5 says use the amplitude to plot the 5 key points of the cycle. So our amplitude is 3. That means when I'm from my midline up to my max should be a distance of 3. So we're down at -1, 0, 1, 2. So that would be 1, 2, 3. So at pi over 2, I'm up at 3. So I'm just following this shape, right? Where we go midline, max, midline, min, midline. So midline, max. At pi, I'm going to have to be at midline. At 3 pi over 2, I'm going to have to be a distance of 3 below my midline. So 1, 2, 3. And so I see one cycle of my function looking like this. And so a midline, y equals -1, amplitude of 1, 2, 3, up to the max, an amplitude of 1, 2, 3, down to the minimum. We see our 1, 2, 3, 4, 5 key points spanning 0 to 2 pi. So we're told to build the rest of the curve by repeating the pattern of the 5 key points. Okay, so I'll repeat the pattern. I left off here at the midline. All the way over here at, let's say, 4 pi, I'm going to be at the midline again. Halfway between that will be midline. Halfway between those 2 points on the midline will be our max. Halfway between the second 2 points on the midline will be our minimum. I'll throw arrows on there because this continues forever and ever. And I'll continue this on the left-hand side as well. So just partitioning that up to help myself go from midline in this case, down to minimum, back to midline, up to max, back to midline, down to minimum, back to midline, up to max, back to midline. And just do our best to connect in a nice smooth curve. Say, hey, that goes on forever and ever. Alrighty, so you have practice 1, 2, and 3 to do on your own. There is on all of those a check work button that will be available to you once you do your own sketch. Okay, so we're really focusing here on how the amplitude and the midline, the equation of the midline changes our sine and cosine curves. So go ahead and pause this video, tackle practice 1, 2, 3. You can use that check work button to see how this is going for you. Make note of any questions that you may have. All right, so hopefully you have done practices 1, 2, and 3 if you are still listening. We're gonna work on what happens when that amplitude is negative, or that A value is, sorry, not amplitude is negative. Amplitude will always be positive, but an A value can be negative, which will cause that vertical reflection in our curve. So really the steps stay the same, but this cycle kind of changes, okay, because of this negative value. So we're still going to sketch and identify the midline. I see that there is no numerical value added or subtracted to the trig term. So I'll plot an amplitude of y equals 0. I'm going to determine if the curve starts at the midline, meaning it's sine, or a max or a min, meaning it's cosine. I see that it's sine, so I will start at the midline here. Marking off that period, again, for our purposes today, it's going to be 2 pi. We'll see that change tomorrow. And then dividing that into fourths to allow ourselves to traverse from midline, min or max, midline, min or max, midline. So I already know what this point is at least. All right, use the amplitude to plot the 5 key points of one cycle. So the amplitude is 2, but the negative causes a vertical reflection. So instead of going from our midline up to our max, we're actually going to go midline to our minimum, back to our midline, then to our max, back to our midline. Okay, so this vertical reflection changes. So instead of midline to max, we go midline to minimum, right? Minimum is how far away, 2 units, because that amplitude is 2. So we are going to have to drop down 2 units to our min, back to our midline, up to our max, back to our midline. So our curve actually starts kind of in a different direction, right? We've seen that sine typically is midline, max, midline, min, midline. But if I throw a negative out front, we're going midline, min, midline, max, midline. So very similar to what we've seen with our work in previous functions. Okay? But from here, we're going to just keep building the rest of this by repeating those 5 key points. So we left off at our midline. We know we have to go to the minimum, return to our midline, up to the maximum, return to our midline for a second cycle, ending at 4 pi, but we let go on forever. We'll repeat that on the left-hand side. Here would be negative 2 pi, negative 4 pi. We left off at the midline, so we have to make this match. So careful, don't go minimum, right? Because to repeat this behavior, we're actually going to have to go up to the max on the left-hand side, down to the midline, sorry, then to the minimum, back to the midline. So here's a second cycle, repeating again, max, mid, min, mid, and then forever and ever. All right. I want to talk about together practice 4, just to see how that reflection impacts a cosine curve. So our steps, again, identify and plot the midline. So our midline is positive 1. Our amplitude is 1, so I'm going to be bouncing between the values of 2 and 0. But again, that vertical reflection, instead of starting at a max, we're going to have to start because it's a cosine, right? We're used to starting a cosine at a max, but because of the vertical reflection, we're going to start at a minimum. So cosine we've seen in our work so far of going max, mid, min, mid, max in a nice curvy fashion. If we throw a negative in there though, we are going to start minimum, mid, max, mid, minimum. Okay, so instead of starting up here, our cosine curve is going to start down below. But I follow that same pattern, right? At 2 pi, I'm going to return to that midline, or that minimum, I'm so sorry. So I have to cycle through minimum, they're very similar words. Minimum, midline, maximum, midline, minimum. Forever and ever. We'll repeat that on the other side. So we left off here at the origin at a minimum because of that negative out front. We'll have to build up to our midline, to our max, back to our midline, and ending at our minimum. That's good news, right? We want to end where we started after one full cycle, one full period. So we connect in a nice smooth way, and then we can click this button and check our work, and hopefully I've set it up correctly that you'll get a nice smooth curve tracing over your sketch. Practices 5 and 6, very similar, dealing with that vertical reflection out front. So go ahead and tackle those, checking the key at the week at a glance, making note of any questions that you might need to ask me.